finally, let's consider an example. So let's consider an example where we determine what the modulation index mu should look like if we have a message that contains just a single tone. Okay, so we're going to call this, right, a message that contains a single tone, 1 omega m, our message, just one message frequency. And so you might call this tone modulation, because all you're doing is having a message that's a single tone and you're modulating it, moving it up and down to your carrier frequency. Now, in this tone modulation, we can see that the amplitude of our tone, our message tone, is B. So this is some B that our message goes, right? So if we have this cosine wave, it's going up and down between B and minus B. All right, so clearly our maximum is B and our minimum is minus B, which means that our M max is equal to our M min, right? This is equal to this, of course. So therefore, we can consider this to be that first category, that symmetric category, the zero offset category case for our selection of A. And to do this, right, we'll choose our modulation index such that the maximum value divided by our A is equal to the index. And in this case, our MP is equal to B. So our modulation index is going to be mu. Our modulation index mu is going to be equal to B over A. And so therefore, B could be rearranged to be equal to mu, the index, times A. So therefore, we could rewrite this so that our amplitude is changed to being the index multiplied by our A, and we can bring it up here. So we'll change our message. We will rewrite our amplitude of the message as mu times A. So when we have done this, right, let's consider what the modulated signal will look like. Okay, so our modulated signal for the AM case, we know that we are adding A plus our message. So our message has some extra A added to it, and it's being multiplied by a cosine wave with a carrier frequency omega c, right? And this is the frequency that we're modulating with. So if we are to substitute our message, right, so our message here, if we were to substitute this into MT, right, we're going to get this result here, where now we can see that there's A in this term and this term. So we'll bring that apart, and we can see that the modulated AM signal in time is equal to this equation that we have here. Okay, so let's look at this graphically, and let's see, right, if we wanted to change A and the index, let's see how this changes things. So our original message, right, is a single tone. So it's just a cosine frequency, going from B to minus B. And if we choose a very small modulation index, where, remember, our modulation index is B over A, this means that our A was really big while our B stayed constant. So when you have a whole bunch of extra A, you can see that this really made the amplitude of our modulated signal really big, right? So instead of being from 1, it goes all the way up to 10. So now we have these really high amplitude waves. The scale is off between these two, but you can see that the envelope up top is the same, contains the same information as the message, because the envelope rate never drops below that 0. Now, what if you chose the largest index possible? Recall, right, we had that criteria that our index should be such that it was between 0 and 1. If we make it the largest index possible, then we can see that the amplitude of our modulated wave does go up to 2. So that makes sense, right? Because if we were to shift our original message so that it was all the way at 0, we could see that this would be shifted up to 2. And so by selecting the largest index possible, right, we've lifted the bottom of the message up to that bare minimum, right? We've lifted it up to the bare minimum so that now the envelope is just grazing, just touching this 0. And if the envelope, right, if we had selected an A any bigger, that would mean that mu would be larger than 1. And that would mean that this, right, the envelope might go just below here, and then it would have that little extra bounce. And then all of a sudden, our envelope, right, is no longer containing the same information, right, because this does not have that bump. So if you made your mu, that index, bigger than 1, right, you're no longer going to have the same information in your envelope. So this is a little bit of a graphical example where our message is just that single tone. Thank you, and see you in the next set of videos.